Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers averages and dispersion. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. What is the name given to the most frequent item in a list? Circle your answer. Is it the mean, the median, the mode, or the range? Well, mode means most, median is middle, and mean is where you add them all together and divide by how many you got, so it's that one, mode. What is the mode of these numbers? Now, mode means most, and you can see we've got two sixes here, and all the other numbers there's only one of. So there are more sixes than any other number, making 6 the mode. Question 23. Which one of the following is discrete data? Circle your answer. Okay, so if you didn't know this already, there are two types of data that you can get: discrete data and continuous data. Discrete data is data that has particular states it can be in. So it could be just all whole numbers or a particular number. Continuous data could be any value between a given range. So if you think about the mass of a television, that could be any number. Time taken to deliver a television could be any number. Time is continuous, mass is continuous. Height of a television mast, that is continuous as well, and numbers of televisions sold. Now that is the discrete one, okay? Whilst you could have a mass of, I don't know, 25.36 kilograms and a time to be delivered in a fraction. You can't have a fractional number of televisions sold. You sell a television, or you don't sell a television. Not many people go up and buy a part of a television. So number of televisions sold is the discrete data. Circle the expression for the range of n consecutive numbers. Okay, so first off, what does range mean? Range means highest minus lowest, doesn't it? So range equals highest value minus the lowest value. Okay, now let's consider our n consecutive numbers. Now we don't know what the first number is, so let's call it a. Now my next number is going to be one more than that because these numbers are consecutive, so I'm going to have a plus 1. Then I'm going to have a plus 2, and then so on. Now what's my last number going to be? Now it's not going to be a plus n, because that means I would have n plus 1 numbers. So it's got to be a plus n minus 1, giving me n numbers altogether. Okay, so then if I take my highest number, a plus n minus 1, and take away my lowest number, a, then my range is going to be a plus n minus 1 take away a, which is n minus 1. So it's that one there. Okay, question 7. Here are a list of numbers: 21, 17, 23, 21, 29, 32, 21, 25, 36. Work out the median. Right, when we're working out a median, the first thing we need to do is put the numbers in order of size, smallest from biggest. So what have I got? I've got 17. Let's put that one down first. The numbers starting with 2. I've got 2 21s, 21, 21, oh, and another 21, 21, 3 21s, a 23, a 25, what else have I got? I've got a 29, a 32, and a 36. Okay, just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Got my 9 numbers down. Okay, so now I've got them arranged from smallest to biggest. Then the median is going to be the one in the middle. So you can either count in from both ends. So like, not that, so counting in from both ends like this until you've got one left in the middle. Or you can say, well, I've got 9 items, add 1, divide by 2. 9 plus 1 is 10, divided by 2 is 5. So the answer is the 5th number. So first, second, third, fourth, 5th value. That's the other way of doing it. Okay, so either count in from both ends until you meet in the middle, or work out where the median should be. Either way, the answer is the same. It's going to be 23. Question 10. Here is a list of numbers. Work out their median. Okay, now to find a median, you need to arrange the numbers from smallest to biggest and then find the number in the middle. Okay, so I'm going to do that first. I'm going to go through my list and rearrange it. So I've got a 1, I've got 2 2s, I've got a 3, I've got a 4, I've got 1, 2, 3 5s, 5, 5, 5. I've got a 6 and I've got an 8. Okay, so I've rearranged them from smallest to biggest. Now, how many of them are there? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers altogether. So 10 numbers altogether. So my middle one you can find by adding 1 and dividing by 2. So your middle number is your 10 plus 1 divided by 2. 10 plus 1 is 11 divided by 2. That tells me my median is going to be the 5.5 number, or halfway between the 5th and the 6th number. So counting in 1, 2, 3, 4, 5. That's my 5th number. That's my 6th number. So my median is going to be kind of halfway between those two numbers then, isn't it? So halfway between 4 and 5 is 4.5. Okay, so that's my median, 4.5. Alternatively, if you don't like using this n plus 1 over 2th way of working out where the median is, you can kind of come in from both ends. So you can kind of say, count in. So 1, 2, 3, 4. So I count in from both ends until you're just left with 1 or 2 numbers in the middle. Do it that way. That also works. Okay, 10b says work out the mean. So the mean is going to be all those numbers added up divided by the total number of numbers. Now I already know that there are 10 numbers because I counted them earlier. But what do my numbers add up to? I've got 1, 2, 3, I'm just going to add these up. 1, 3, 5, 8, 12, 17, 22, 27, 33, 41. So they add up to 41. There were 10 numbers altogether, so dividing 41 by 10, just move the decimal point 1 across, it gives me 4.1. So my mean is 4.1. Okay, in this question, it's a bit of a puzzle. I've got 5 integers, and I know that the mode is 6, the median is 8, and the mean is 10. And I have to use these bits of information to work out what the greatest possible range might be for those 5 numbers. So let's go through one piece of information at a time and see if we can piece it all together. Now the first piece of information is that there is a mode of 6, which means there needs to be at least 2 6s in my 5 values. Right, so I've got 5 spaces to fill. Okay, now I know that 2 of them must be 6s at least. There might be 3 or more, but we know that must be at least 2. Now it's got a median of 8. Now because there are 5 numbers, the middle one must be 8, which means because I have to have 2 6s, that these 2 here must be the 6s. So I've got rid of those. Okay, so I've got 6, 6, 8 and something and something. Okay, so I've dealt with my mode of 6 and my median of 8. Last piece of information has a mean of 10, which means if I add them all up and divide by 5, I should get 10. So 6 plus 6 plus 8 plus something, that's going to be equal to 50 then, isn't it? Okay, which means that these two numbers together has got to be the difference between 50 and 6 plus 8, which is 20. Now clearly they need to be bigger than 8, otherwise I'm not going to have 8 as my median. The first number can't be 8 because then it would be bimodal. So the smallest value this one can be is a 9. So then the largest one that this one on the end can be is 21. Does that work? 6, 12, 20, 29, 30, 50. That's right, isn't it? So then the range of this is going to be 21 minus 6, which is 15. That's the largest it can be. So what is the greatest possible range? The greatest possible range is 21 minus 6, which is 15. The range of a set of numbers is 15 and a quarter. The smallest number is -2 and 7/8. Work out the largest number. So range, if you remember, is defined to be the largest value minus the smallest. So if we rearrange that, move that over there, look, then the largest value is going to be the range plus the smallest, isn't it? So I'm going to find it by adding my two fractions together. So in this case, it's going to be my range, which is 15 and a quarter, plus my -2 and 7/8. And now adding a negative is the same thing as taking away. So that is the same thing as those two things subtracted from each other. I'm just going to write them as top-heavy fractions now as well. Should I do that? Yeah, let's do that. So 15 fours are 60, plus 1 is 61 quarters. So I've got 61 quarters minus 2 eighths are 16, plus 7 are 23, so 23 eighths. Okay, so subtraction, I need a common denominator. So just doubling up those two numbers there, so we change it into an equivalent fraction over 8. So 61 times 2 is 122 eighths. So 122 eighths minus 23 eighths. So subtracted numerators, that's going to give me 99 over 8. Do we have to give it in a certain form? It just says work out the largest number. Got 99 over 8. Shall I write as a mixed number? Well, 8s into 99 go 12 times, don't they? 12 eighths are 96. So it goes in 12 times, remainder 3. So it's 12 and 3 eighths. Again, I think 99 over 8 is probably a more useful number to deal with and would still get you all the marks, I think. Doesn't say write as a mixed number, but either of those will get you the 3 marks. Okay, question 13 asks, what percentage of a distribution is covered by the interquartile range? Okay, now let's think about this. Interquartile, if the range of numbers goes from the highest to the lowest value, and Q1, our lowest quartile, is 1/4 of the way through, and Q3, our upper quartile, is 3/4 of the way through. So our interquartile range then covers all the data but in between. So we've got our median in the middle, haven't we? Q2. So between Q1 and Q2 we've got 1/4 of the data, and between Q2 and Q3 we've got 1/4 of the data. So between Q1 and Q3 we must have half of the data, which is 50%. So the interquartile range covers 50% of our data. Question 20. In 1 month, the number of hours of exercise taken by 10 people are 4, 7, 2, 8, 6, 5, 1, 82, 3, and 9. Which is the appropriate average to use in this situation? Is it the mean, the median, or the mode? Now, I think the most appropriate one for this group of data would be the median. Now, why do I think that? Firstly, I don't think the mean is appropriate because of this value here. You notice much bigger than the others. Okay, we call that one an outlier, and if I add all those numbers up and divide by how many I've got, then that 82 will have disproportionate effect on the value of the answer I get. So I'm going to write down that 82 is an outlier, some crazy fitness freak in there, and will have a disproportionate effect on its value. Okay, so that's why I don't think the mean is appropriate. Now, I don't think the mode is appropriate because all the numbers are different. So, and if all the numbers are different, there is no mode. Oh, I forgot to say what that was. So just on the value of the mean, I should write down there. On the value of the mean, and here I can write all the numbers are different, so there is no mode. So it can't be very appropriate, can it? Okay. The 5. So that's actually saying 5 is greater than x, or x is less than 5, not greater than 5. So it's not that one either. Just by looking at the first part, you can work out that it's actually x is greater than 5 is that one, and strictly less than, oh sorry, less than or equal to 9. So it is that one on the end there. Question 19. The following data comes from a large sample survey of the audience at a concert. So we've got male and female on one side, and we've got a percentage. So that's a percentage, I suppose, of how many people attended. Their mean age and their age range. Okay, so let's make 3 comparisons of male and females at the concert using the headings given. Okay, so the proportion of the audience. Now the proportion is how many males there are to females, aren't there? And you can see here that there are many more males than females. So I'm going to say there are many more females than males at the concert. Okay, and the next one wants us to look at their average age. Now we've got their mean age here, haven't we? So we can say that on average the females were older than the males. The females were older than the males on average. And what's the last one? The spread of their ages. That's the age range up here, isn't there? So there's more variation in the females' ages than the males. There is greater variation in age range for the females than the males. Here we go. Question 18. The following data is about the same types of plants. Some of the plants are treated with plant food, and we've got some data for untreated and treated, and their mean height and their interquartile range. So compare the untreated plants and treated plants. Okay, so comparing their mean heights, we can see that on average the treated plants have a greater height than the untreated plants. So let's write that down. On average, the treated plants are
taller, 35.1 centimeters, than the untreated plants, which are 30.2. So that's one comparison. The next comparison, we're going to look at the interquartile range. Now we can see the interquartile range is larger for the untreated plants than the treated plants, which means that there's more variation within the untreated group. Conversely, there's less variation then between in the treated group. So there is less variation in height for the treated plants compared to the untreated plants.
Question 15. 100 men and 100 women took a test, and here are their scores. So we can see men had a median of 28, an interquartile range of 7.5 and a range of 31, and women had a median of 30, an interquartile range of 9 and a range of 37. Using this data, which statement must be true? Tick one box. Is it true that men had a higher average score than women? Well, no. That one isn't right, is it? Okay. Men had a median score of 28 and women had a higher score of 30. So that one is definitely out. Right, what's next? Men had more consistent scores than women. Now, consistency is a measure, or as a kind of a quality of dispersion, how widely dispersed your data is, or what the range is. So interquartile range and range are both measures of dispersion. Okay, we would say that interquartile range is probably a better measure than range. Range is madly affected by your highest and lowest points, which can often be outliers. So interquartile range ignores the top half and top quarter and bottom quarter of your data, so it's often a much more reliable measure of dispersion. But anyway, just need to compare the two. So you can see here that men had an interquartile range of 7.5, which means it's less spread out than the women's score of 9, and they also had a smaller range than women, which was 31 to 37. So I would agree that men had more consistent scores than women. There was less variation between the men's scores compared to the women's scores. So less variation means more consistency. So I'm going to say that one is true. Let's just double check the last two. Women had the higher score. Well, there is no way of telling that from the data. You can't see which is the highest score. You can see that the range is widest for women, but that isn't going to tell you definitely that it's going to be the higher one. They could have the lowest score, and then 37 above the lowest score would still not be the highest score. So we can't tell from that one. It's unclear if that is true or not. A man had the lowest score, and that's the similar argument here. We can't tell from this data who had the highest and who had the lowest. It's not possible to tell. So that is unclear as well from this data. There's only one that I can hand on heart say must be the case, and that is that one then. Men had more consistent scores than women. Question 16. In question 11, we're told that Adam and 6 other men ran a race. The times in seconds of the 6 other men are shown. The mean time for all 7 men was 9.83 seconds. Did Adam win the race? You must show your working. Okay, so we've got the times for the 6 men that Adam raced against, but we don't actually have Adam's time. So let's use a bit of algebra and call Adam's time x to start with. So we would calculate the mean by adding all 7 values together and then divide by 7. So x, Adam's value, plus all the other gents, 9.7, 9, 9.80, 9.88, 9.94 and 9.98.
8, all divided by 7, because there were 7 runners, and we know that that is equal to 9.83. Okay, I think it's time to reach for a calculator. I'm going to cross multiply that up there, so getting rid of the 7 on the bottom, 7 times 9.83, that is equal to, so 9.83 times 7, 68.81. So I'm going to write 68.81 this side, and then on the other side I've got x plus all those other 6 gents times. I'm going to quickly add those up. 9.75 plus 9.79 plus 9.8 plus 9.88, 9.94 and 9.98, which comes to 59.14. 59.14. Okay, so now we just need to solve for x, taking my 59.14 to the other side and subtracting from my other value, so 68.81 minus answer 9.67. So did he win the race? Yes, because his time is faster than everybody else's, so I can answer yes. Adam ran the fastest time, so won the race.
Question 18. Here are 5 cards. They're labelled 1, 5, 7, 9 and 11. One of the cards is removed. The mean of the numbers on the remaining 4 cards is 6. Which was removed? You must show your working. Okay, so if I remove a card and only have 4 cards left and the mean is 6, then the total on those 4 cards is going to be 4 times the mean, isn't it? Because that's how you get a mean. You add up all the numbers and you divide by how many you've got, and that tells you the mean. So if I times the mean by the number of things I've got, it tells me what the total is on all 4 things. And 4 lots of 6 is 24. Now currently those cards add up to, what do they add up to? 1 plus 5 is 6, plus 7 is 13, plus 9 is 22, plus 11, 32, 33. They add up to 33. So if I want to reduce them from 33 to 24, I need to subtract 9. Okay, so 33 subtract 24 is 9. So I need to remove the 9 card. The 9 was removed. Okay. At a nursery, the mean age of 4 children is 31 months. Katie joins the nursery. The mean age of all 5 children is now 30 months. Work out the age of Katie. So let's take this first statement here, that the mean age of the 4 children is 31 months. Now if their mean age is 31, then we can work out the total ages of those 4 children by multiplying 4 and 31 together. So total ages of 4 children, can't spell children now, children equals 4 times 31, which is 124. Then the mean age of all 5 children is 30 months. So total ages of the 5 children is going to be 5 times 30, which is 150. So then Katie's age is going to be the difference between those two then, isn't it? So Katie's age
equals 150 subtract 124, which is 26 months. That kind of makes sense then. So when she joins the nursery, the mean age drops a little bit because she's younger than the other children on average. Question 11. In rectangle A, there are 6 masses. We've got 1 kg, 5 kg, 750 grams, 250 grams, 300 grams, and 2 tons. And part A says, show that the sum of the 6 masses is 2007.3 kilograms. So basically, we're going to have to convert them all to kilograms and add them all up. Okay, so what have we got? We've got 1k and 5 kg. They're all fine. 2 tons is the same thing. A ton is 1,000 kilograms. So 2 tons is going to be 2,000 kilograms. 250 grams, that is 0.25 kilograms. 300 grams is 0.3, and 750 grams is 0.75 because there are 1,000 grams in a kilogram. So adding all those up, so total equals 1 plus 5 plus 2,000 plus 0.25 plus 0.75 plus 0.3. Let's just check that that does actually add up as we think it does. So 1 plus 5 plus 2,000 plus 0.25 plus 0.75 plus 0.3. Yeah, 2007.3. Part B says 3 of the masses are moved from A to B. The mean of the masses in B is now 2.1 kilograms. Which 3 masses move? You must show your working. Okay, so we're going to pick 3 of these and move them over, and it has to have a mean of 2.1 kilograms. So a mean is what you get when you add all of the 3 weights together and divide by how many you've got. So your 3 values, x plus y plus z, you add them together and you divide by 3, and that gives you 2.1. Okay, so from that we can work out what the total should be. If I take 3 and I times it by 2.1, that will tell me the total mass of all 3 is going to be 2.1 times 3, which is 6.3. So we need to pick out 3 weights that adds up to 6.3. So which ones must it be? Well, I've got a 0.3, so it makes sense to pick that one. That's going to give me the 0.3. Now I need 2 that add up to 6. Those 2. So I need the 1 kg, I need the 5 kg, and I need the 300 grams. Okay, and that will add up to 6.3 kg and have a mass, a mean of 2.1. So 1 kg, 5 kg, and 300 grams. Okay, if we know the mean height of the boys is 1.58 and we know there are 12 boys, if we multiply those 2 together, we'll get the sum of their heights added together, won't we? So the sum of boys' heights is going to be equal to 12 lots of 1.58. So the heights of all the 12 boys are going to add up to 12 times 1.58 is 18.96. So they all add up to 18.96. And we know that the mean height of all 28 students is 1.52 meters. So the height of all students equals 28 times 1.52, which adds up to 28 times 1.52 adds up to 42.56. Okay, so the girls' height then, the sum of the girls' heights is going to be the sum of all students, subtract the sum of the boys' heights. In other words, it's going to be 42.56 subtract 18.96, which is 23.6. So we know then that girls' heights add up to 23.6, and we know how many girls there are because there are 28 students. So assuming that the rest of the class that aren't boys are girls, that would give me 16 girl students, and I know that their total height is 23.6. Then the mean height of the girls is going to be that total 23.6 divided by the number of girls, which is 16. Which would make their mean height 1.475. 1.475.
Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.